Hi, today we're going to do 5.7, and it involves some a slightly more complicated formula to do with arc length. And when I introduced arc measure, I'm trying to see if it's on here. Yeah. The arc measurement, I emphasized the word measure versus the word length. To review, the arc measurement is equal to the central angle. But the arc length, again, it's like attaching a piece of string along here and ending it and then pulling the string straight. That is a distance, a linear distance, not a how wide open is it kind of a thing. It's also a portion of the circumference. The circumference is all the way around the circle. So it's just a part of, a portion of. So the question is, what portion of the total 360? So we use this over here. We take the arc measurement, whatever it may be, its measure from up here, out of its total. This is the part of the total. A fraction just means a part of something. So this fraction is part of the entire circumference. So that's how we'll set up the problem to solve arc length. We'll have the arc measure over 360. It's always over 360 because a full complete circle, of course, is 360 degrees. And then we multiply that by the circumference. So that's the plan for today's lesson. So let's start. I should have started with warm up and then introduce that, but there we go. I'm a little backwards. Here we go. These are review problems from the last two sections we did. So we have two chords that intersect we've got an angle inside the circle. They want to find angle AED. AED is right here. That's our question. And there's a formula for that. And we could say angle AED is, you might remember, half the sum of the two arcs created by those two chords. So the sum of 32 plus 15. I'm not going to solve today. It's like add it, divide by 2, and you're done. Not to be confused with two secants in a circle that create an angle outside the circle. Oops, I didn't write what I'm supposed to find. It's supposed to find angle MNO. Angle MNO, which of course is that exterior angle there. And there's a formula to find that. Angle MNO is also 1/2, but it's the difference of the two arcs. And we start with the larger arc. Oh, that's not going to write. Little sloppy, trying to make it show up a little better. The larger arc, and that is 136. Subtract the smaller arc, this guy right here is 25. And again, I'm going to let you do the math. You do this subtraction, come to us as parentheses first, and then divide by 2. Okay, so those are very similar formulas. The only difference, no pun intended, is this one is a difference and this one is a sum. Maybe to help you remember it, you can see that when they cross inside, it almost looks like a plus symbol. And outside there's no plus, but like one of these you could call the negative. That's subtract. I don't know. I'm trying to find tricks to help you remember what's what. But you've also got your notes in front of you. All right, so we went over the notes. Now let's do a little bit of 5.7. They give us, again, that formula here. The arc length, the word is length, that's different from measure, is the measure of the arc over 360 times the circumference. Well, first they want us to practice finding the circumference. A big mess of pens rolling into my work. So let's find the circumference. Just to remind you, oops, that's not what I want. Circumference is up top again. Circumference is 2 pi r, or circumference is diameter times pi, which makes sense because 2 r's, 2 times the radius, is the diameter. So if they give you diameter like this one, you could just use diameter times pi. But they give us the radius, so we'll write circumference equals 2 pi times r. And then we do our calculations. No, what did I do? Oh, I did something funny. Anyway, we do our calculations. 2 of the 12.4s is 24.8 times pi. And then if we want an exact answer, that would be it. But Apex is going to ask for an estimate. So 24.8 times pi is going to look like this. I want you to see. What am I doing? Oh my gosh. So much going on there. Okay, so what is it? 24.8 times pi. 24.8. You don't have to hit times pi, just the pi, which is right here. And since it's yellow above the button, we hit the second button first to access that function. And then hit enter. The calculator knows to multiply. So Apex, I think, is going to round to the hundredths. So it will stay a 1 here. So 77.91. 77.91. Okay? And that is what Apex will give you. Circumference. All right. I'm going to let you do 2 and 3. Let's look at number 4. Sorry, I got you dizzy. They give us the circumference of a circle. It is 20 centimeters. What is the length of arc AB, the minor arc? So they want the length of this, like a piece of string is on it. So we learned a minute ago that we take the measure of the arc over 360, multiply it by circumference. Well, they gave it to us, so that's nice. And that'll give us the length of the arc. There's a few things we could do. I kind of like the idea of simplifying across the way, like make this a fraction and would multiply straight across, but those are such big numbers. I could divide by 10 and get rid of those 2 zeros. And then we also know that 2 goes into 36. So 2 goes into 2 once, into 36, 18 times. And now I've got 1 over 1, so that kind of disappeared, and I've got 95. Let's rewrite it so it's a little cleaner. Over 18 equals what we're looking for, the length of the arc. And then it becomes calculator work. And again, you could have, since it's calculator in the end, you could have just multiplied straight across and then divided by 360. But I think my habit is to just try and simplify a little bit. So this comes out to 5.2777, and it continues, and we'll round it to 28. The arc length is 5.28 centimeters. I should have put centimeters there. Okay? Again, you could have just multiplied 95 times 20, then hit divide by 360, and you'd get the exact same answer. So let's set up 5 just for another. I'm going to let you solve it, but I'll help you set it up. And 5 and 6 are exactly the same. By the way, 6 got cut off. It's 55 centimeters. These are exactly the same. So we take the arc measurement, 15 over 360, always over 360, times the circumference, which is 33. And you can just go, like I said, straight to calculator. Multiply those two, then divide by 360. I'll let you finish that problem. 6 is exactly the same. Number 7. What's the length? Same problem, but this time they don't give us the circumference. So we're going to have to figure it out. So let's set it up the same though. Let's see, we're looking for AB, that's this. The central angle is 170, which means the arc measure is 170 also. So we have 170 over 360 times the circumference. Well, the circumference is 2 pi r. So 2 pi r. I'm going to put that over 1 just because this one's a fraction. We could make that one a fraction to make it a little easier. And then we'll just start simplifying. I'm going to, again, reduce this by 10, divide by 10. That's not going to reduce anymore. But over here, I can reduce anything. This whole thing here is the numerator. It's 17 times 2 times pi times 8. And the denominator is 36 times 1. Well, so I can reduce any part of those. I can reduce the 36 and the 2. 2 goes in there once. 2 goes into 36 9 times. No, what am I saying? Oh, I know what I did. Not 9 times, 18 times. Sorry, I was looking at my note. I'd done the problem ahead and I did it a little different, which is fine. And now I can reduce again. 8, 2 goes into 8 4 times, 2 goes into 18 9 times. And that's looking really messy now. Let's go 17 times 4 times pi. 17 times 4, I'm going to check that one. 17 times 4, yeah, is 68. So let's continue down here. 68, and don't forget we have a pi up there. And the 1 is times 9. That's our new simplified mess. That was kind of a mess. Sorry about that. Anyway, it's all going to end up being calculator work. You can just put it all in at this point. So, and I froze. Darn it. Okay, well, fast forward till I get things back up and running. It's almost there. I'm still here. Okay. Hopefully you can see it. Gosh darn it, I don't know if you can, but I'm hoping. Okay, so we're going to go 68 times pi. 68, we don't have to tell the calculator to multiply. It knows when I do pi, I'm multiplying right next to it. It's like, no, I'm not, I was going to say it's like a variable. It's not a variable at all. I'm going to hit enter. I could have surrounded it by parentheses to put it all in at once. Enter and then divide by 9 to get that denominator. We have 23.736, blah, blah, blah. Let's round to this one. That's going to make it a 23.74. 23.74. And all the while, it's in centimeters. All the while, I could have put this whole original problem in my calculator all at once without that mess of simplification, but I just kind of liked simplifying. But let's watch how it works. We could have done 170 times 2 times 8 times 2 times 8. Actually, clear out. I'm going to put it all in a parenthesis. 170 times 2 times 8 times pi. That's the numerator. Surround it by parentheses. And then divide by 360. Divided by 360, and we'll get the same answer. I just did a whole lot of simplifying because it was fun. But since you're going straight calculator work, you probably could just go this method. Make sure to surround the numerator by your parentheses and then divide by 360. Okay, boy, I feel like I kind of botched that, but that's okay. All right, number 9. The length of arc AB is 10. This time they give us the length. We have to find the circumference. Well, we're going to use the same setup. Remember, up here, all of this was to find, all of this was to find the length, right? And right in here, we put in the circumference, okay? Now we have the length, so I'm going to put my length value, which is 10 centimeters, on the right side, and I'm going to put equals C for circumference, and then whatever other information you'll need to solve it. So it's going to look like this. We have the arc measure over 360 times the circumference, which I don't know, equals the arc length, which I do know. And so to solve this, again, I really want to reduce that. I could reduce it again, but it's going to wind up being calculator work. No, let's reduce it again. 1 goes into that. 3 goes into that once, 3 goes into that 12 times. Now I have 1/12. Let's rewrite it so you see what I'm talking about. So I reduced this fraction to 1/12. To get rid of a fractional coefficient, we multiply by its reciprocal. Multiply by 12. These become a 1, or you might say cancel out. but they really become a 1, and we get 120 is the circumference, and this is in centimeters. 120 centimeters. Okie doke. I think I should probably help you set up 10. It's the exact same problem, not to mention it's cut off. It says the arc length is 24 centimeters. That got cut off. What's the circumference? I'm going to let you try it and check solutions. Let's call it good. I hope that all worked because I got frozen in the middle. Have a great day.